What's good, everybody? This is Green Spinach Show, and I am bringing you another episode of Math, Science, and Modern Warfare 3. And today we are gonna kind of take a different trip today, and we're gonna talk about organic chemistry. And I know what you're thinking. You're like, but Matt, you have a degree in math. Are you really able to talk about this? And I'd say yes, I am. Before I decided to switch my major in college to math, I was a pre-med major, and I have 2 years of chemistry under my belt, so I do know what I'm talking about, although it may be a tad rusty. So we'll see how good we can get through this. Now, today we're going to be talking about the SN2 reaction, which is a nucleophilic substitute reaction, and it's said to be second order overall. Now, which is why it's called SN2. Now, you're probably thinking, Matt, you're obviously missing something. Isn't there an SI1? And yes, there is an SN1. We'll be talking about it in a later video. But I feel that teaching this reaction first is more easier, and it kind of preps you for the next one. And then, as a caveat to this, again, I'm 2 years, almost 3, rusty on this material, so we'll see how good I can get through it. Also, if you want to draw these types of molecules, go online and search ChemSketch. It is a freeware program where you can draw very, very similar diagrams to this, and we'll see how we can get. You'll see how we can get through this. Now, we're going to be talking about the SN2 reaction. So, let's just start off with this chemical equation, right? We have an OH minus plus CH3Cl, and that mechanism will lead to a CH3OH plus a Cl negative. Now, of course, the idea behind this reaction is the movement of electrons, right? Which I like to call reaction arrows. And the great thing about organic chemistry is that once you kind of get the ball rolling, it can't stop. So you'll see what I mean by all the arrows. You can just see how it just forces everything to move over, and it kind of makes this somewhat easy. Now, this reaction proceeds in a single step without any intermediates. Now, and this is because it proceeds through an unstable arrangement of atoms called a transition state, and we will look at that in a future picture. Now, this reaction is said to be concerted because the bonds forming and breaking in this reaction will occur simultaneously through this transition state. And so don't be concerned about this transition state, though, because according to experiments, it only lasts about 10 to the negative 12 seconds, which, if you are wondering, is about the amount of time required for one molecular vibration. So that's pretty cool. And now, the SN2 reaction always occurs with an inversion of configuration, and you'll see this on the CH3Cl molecule in this reaction. So, let's talk about the first picture, right? We have a partially charged carbon, and of course, the negatively charged oxygen molecule will, of course, be drawn to it. So, the negative hydroxide ion, which is that OH, it'll bring a pair of electrons to the partially positive carbon from the back, right? And this is standard with SN2 reactions. It always occurs from the back. And yeah, it's a great sex joke. Chemists do it from the back. I don't know, something like that. But that's how I remember it. Now, and of course, this is when this happens. You know, the electrons get pushed, right? Hence that arrow. From the carbon to the chlorine, and now the chlorine, right? It's starting to get, it's breaking away. It's moving away with the pair of electrons that it's bonded to with the carbon, right? And this makes sense because the carbon is going from that partially positive charged state to a kind of a neutral state. Now we head into the transition state, which is this picture here. Now, that double dagger you see by those brackets, that simply means transition state. That's all it means. Again, like I said before, it's very hard to notice this. It's very hard to you're not going to kind of see this unless you have an amazing computer and microscopes and all that shit. But needless to say, in the transition state, the bond between the oxygen and the carbon is partially formed, and the bond between the carbon and the chlorine is partially broken, and the configuration of the carbon atom begins to invert. Now, what that means is you can see those dashed lines between the oxygen and the chlorine. Those mean partial bonds, and right, so this is a transition state, so those last for a split second. And now, in this picture here, which is the last one, you can see that now the bond between the oxygen and the carbon formed, right? You can see that, and the chlorine icon has left. So, and the configuration of the carbon is inverted, and this is what I was talking about with the inversion of configuration. And now, the idea behind this is, at least, the nucleophile, which is the oxygen in this case, will kind of attack the carbon group from the back and just push everything over and just pop that chlorine right off. So that is how an SN2 reaction works. I know that I didn't explain it as well as I could have, but needless to say, that's usually what happens. Now, I said before that this reaction is said to be second order overall, right? And in chemistry in general, the overall order of a reaction is equal to the sum of the exponents a and b in the rate equation, and that's k times a to raise to the a times b raised to the b. And so it depends about this. So if we had kind of k to the a squared times b, then it'd be second order with respect to a, and stuff like that. Basically, and so it's a bit of a trade-off there. So now I do have to talk about something called HOMO and LUMO electrons, and I know it's kind of yeah, HOMO. I know it's funny, but you say HOMO stands for highest occupied molecular orbital, and LUMO stands for lowest occupied molecular orbital. So you can see how the HOMO begins to overlap with the LUMO of the carbon bearing that chlorine. So yeah, there's a lot more in depth to this. Granted, I am 2 years out on it, so again, I'm just going to apologize right away in case I couldn't explain it as well as I should. And that's it for this video. So thanks for watching. I really do appreciate it. Feel free to like the video, subscribe to the channel. I'm going to be doing all the reactions. There's 4 reactions, and this is the first one. So needless to say, there's going to be more. Feel free to follow me on Twitter @CreamSpinachShow, and have a great